All right, here are the solutions to the three problems that I gave you at the end of the last note. So we have our first example is y is equal to 3 sine squared x. We know that this is the exact same as writing 3 times sine of x squared. So a couple of things to note here. The 3 is not part of the function that is being squared. And so when we go ahead and take this derivative, we're going to be bringing our exponent down. So a 6 times sine x. Our new exponent will be 1, and we need to multiply by the derivative of whatever was in the bracket, and the derivative of sine x is cos x. So y prime is equal to 6 sine x cos x. Our second example is y is equal to x plus cos x squared. So y prime is equal to, we're going to bring down that exponent, so a 2 times, keep that bracket the same. Our new exponent is 1, and now we're multiplying by the derivative of that bracket. So the derivative of x is 1, and the derivative of cos x is negative sine x. Now there's no need to write plus negative sine x. I can just write minus, and I can leave my final answer like this. There's no point in tidying it up right now. I'm okay with the first line. So the third question that I kind of gave you was definitely the hardest one. Before I start, I am just going to go ahead and rewrite this. It is a lot easier to see what's going on when you pull that exponent out. So I'm going to go ahead and rewrite that. So y is equal to cos of 2x all to the power of 3. So when I go ahead and start my derivative, I'm going to bring that exponent down. So 3 times my original bracket, so cos of 2x. My new exponent is a 2. I still need to be multiplying by the derivative of the function in the bracket. So this is even trickier. I have not just cos of x, I have cos of 2x. So the derivative of just a regular cos of x is a negative sine of x. Now, since I have cos of 2x, this derivative is going to be a negative sine of 2x. But I still need to multiply by the derivative of this bracket. So the derivative of 2x is 2. Now that I have this finished, I can go ahead and tidy things up. So I've got a 3 times a 2. There's a negative right here. So y prime is equal to negative 6. I can go ahead and rewrite this as cos squared of 2x. Now that just looks a little bit tidier. And then multiply that by sine of 2x. So to finish off this note, I am going to be going through 3 more examples. So our first example is y equals 2 sine cubed x minus 4 cos squared x. Now I know on the last note I said that I like to rewrite it so that the exponent was on the outside. I'm going to skip that step in this or in these examples just so that you can kind of see both, and then you can make the decision about how you want to do your work moving forward. So dy by dx, again you can just write y prime, it's up to you, is equal to the derivative of this first function right here. So I have my original 2 times my exponent bringing down, so a 3 sine squared x, and we need to multiply that by the derivative of my sine x, so a cos x. Then I need to subtract 4 times, I'm going to bring my 2 down, so 2 cos to the 1x, again you don't need to write that 1, multiplied by the derivative of cos x, which is negative sine x. Now I'm going to go ahead and tidy things up a little bit. I've got a 2 times a 3, so I get 6. Now I like to write cos x and then all of my sine x, probably just because it's alphabetical. It's totally up to you what you want to do. And then we have a negative 4 and a 2 and a negative here. So this is going to be a plus 8 cos x sine x. Now it is absolutely not necessary, but I could factor this. So I've got a 6 and an 8, so I will factor out a 2 I see a cos x in both, and I see a sine x in both. And so when I factor that out, I'm going to be left with a 3 sine x plus 4. So our next example, h of t is equal to sine of 4t times cos squared t. Right away I see that I am going to be using my product rule. I have two functions being multiplied together here. So h prime of t is equal to the derivative of my first function. Now I'm going to do a step that maybe you will have to do in 2 steps, and that's okay. But I do see that I have a 4t inside of the bracket here, so eventually I know that I'm going to be multiplying by a 4. Actually, never mind, I will show you all the steps. I have the derivative of sine, which I know is cos of 4t. I need to be multiplying by the 4, or the derivative of 4t, which is just 4. And then I need to multiply that by my original second function, because of course I'm using the product rule. Plus, I'm going to be keeping my first function, so sine of 4t, times the derivative of that second function. So 2 cos t times the derivative of cos of t, which is negative sine t. And I'm going to go ahead and tidy this up. And I'm going to be getting a 4 cos of 4t cos squared t. I've got a 2 and a negative, so a minus 2 sine of 4t cos of t sine of t. And then, just like the last question, I can go ahead and factor a 4 and a negative 2. So I'm going to be pulling out a 2, and I have a cos of t common here. So I will be left with 2 cos of 4t times cos of t minus sine of 4t sine of t. And in our last example, I have y is equal to cos of 3 theta plus pi by 2. So right away, I'm going to notice there is no x. I'm going to be doing dy by d theta. And that is going to be equal to the derivative of cos of anything we know is negative sine. So negative sine of that original function times the derivative of whatever was in brackets here. So the derivative of 3 theta plus pi by 2. Pi by 2 is a constant, so the derivative of that is just 3. And so when we simplify this a little bit more, we get negative 3 sine of 3 theta plus pi by 2.